Hello everyone. The today's topic of presentation is about the current source inverter fed induction motor drive. Just like voltage source inverter fed induction motor drive, we also can control the induction motor under constant I/of control through current source inverter. Let me define what's a current source inverter. The definition is also like voltage source inverter. The current source inverter is defined as if it is viewed at the terminals of output of the inverter, if they are acting as a current sources, then we will say that it is a current source inverter. Actually, I am using a voltage source inverter here, and how you can control the value of current and how we can achieve this terminals as a current sources, that we will see. So this is a simple. So a voltage source converter, you can easily convert it into current sources by inserting a bulky inductor in series with the voltage source. Voltage where we are giving input to the inverter. Actually, this is my input to the inverter. At the input of the inverter, you just give a bulky inductor in series with that. You can connect it, and automatically the available voltage, whatever there, is converted into constant current. This now input of the inverter itself, it is an current, constant current. Automatically, the output terminals also becomes current sources. Again, we need to see that what is the importance of the rectifier that is used here at the input side. Means that here the voltage source inverter, here I am using this part is voltage source inverter after the inductor. Voltage source inverter will operate in stepped wave inverter mode, that is in 6-step inverter mode. As we know that this 6-step inverter will only controls the frequency but not voltage and current magnitudes inside. The internal control is not having that provision except the frequency control. So that we need to control voltage magnitudes or current magnitudes, whatever we require externally. For external control of voltage to control the current, I used here 3-phase full bridge rectifier. My available supply is the 3-phase AC. I'm going to converting that into variable DC using a 3-phase full bridge rectifier. This variable DC is passed through a bulky inductor. Bulky inductor will makes this variable voltage into a constant current. This magnitude of current here will be depending upon the magnitude of voltage. If suppose the voltage magnitude VD is varied, the magnitude of current is also varied. How we can vary the VD in the sense? By adjusting the firing angle. If you want variable current as input to the inverter, now we are getting constant current for 1 VD. So if you want to variable current as input to the inverter, so that you can regulate the firing angle of the bridge rectifier. Once we regulate the firing angle here, VD is varied, that proportionally varies the ID magnitude. Now variable current source is given as input to this inverter. Obviously, the output terminals also act like a current sources. And these output terminals also now variable current sources. So now by adjusting the firing angles of this inverter in stepped wave inverter mode, we can able to control the time period of the waveform. This time period, if you vary, automatically the firing angle of this inverter is varying the time period of the waveform. Automatically, we can vary the frequency of output of the inverter. Now we have variable frequency by adjusting the time period of this stepped wave inverter, and variable current here by adjusting the firing angle of this rectifier. so that you can have variable current and variable frequency here. This variable current, variable frequency I am using in order to operate this induction motor under I by F control. And every time we must see that the ratio of I by F should remain constant for feasible operation of this induction motor, and in order to keep air gap flux and the maximum torque is constant. The circuit configuration, possible circuit configurations for this type of explanation, we will see in two configuration of circuits. First one, 6-step inverter based CSI for induction motor drive. We already know that the inverter here is acting under the 6-step inverter mode. It can capable of control only the frequency magnitude, but not voltage magnitude. So voltage should be controlled externally. So that available supply is the 3-phase AC, and I used a full bridge rectifier, 3-phase full bridge rectifier to convert that into the variable DC. This variable DC is not directly given input to the inverter. In between, I'm using a bulky inductor in order to make this variable DC as a constant current, and that constant current is given as an input. I already told you this current magnitude is depending upon the voltage magnitude here. For various firing angles, we'll be getting various voltage magnitudes. Similarly, various current magnitudes at the input. So that output current is also a controlled current now. This acting as a current source inverter. And how we can control the firing angle of this full bridge rectifier, in the sense the firing external firing angle control is kept, and by sensing the DC voltage here, so it is taken as input for this controller. So based on this DC voltage magnitude, if suppose you want to vary this DC voltage magnitude, that is passed to the information to the controller, and this controller will function accordingly. It adjusts the firing angle. So that this will be happen here in the 3-phase full bridge rectifier. This controller will adjust the firing angle here, and internally the time period of the inverter can be adjusted during its firing, and if the time is varied by using a firing angle control for the inverter, the time period, it adjusts the frequency at the output. External voltage control is happens through the full bridge rectifier and controller. This voltage controller will give setups the proportional current magnitude. This current magnitude is now provide the variable current at the output. Variable current and variable frequency gives constant I by F ratio control for this type of circuit. Now second circuit, we can see that it's also 6-step inverter based CSI fed induction motor drive. What is the difference between these two circuits, in the sense? Here I use the 3-phase full bridge rectifier. Instead of 3-phase full bridge rectifier, I am using a 3-phase diode bridge rectifier. But diode bridge rectifier is not capable of control the average output voltage here. It will provide a fixed DC. This fixed DC is not sufficient to operate the inverter under variable current and variable frequency mode, so that it is needed to control the voltage. For that reason, I used a chopper circuit, a DC chopper circuit I used. So then what is the necessity of this much setup, in the sense? Here if it is looked at about this full bridge rectifier, it uses a 6 thyristors approximately. And if I see that this chopper circuit, this chopper circuit uses only 1 thyristor. So means that in order to reduce the cost of the circuit, I use this setup. It also employed a diode bridge rectifier. As compared to this thyristors, diode is having very less cost. So that diode bridge rectifier cost also reduced compared to 3-phase thyristor bridge rectifier. So here also the case, available supply is the 3-phase AC. We need to convert that into variable DC. Variable DC is obtained at 3-phase diode bridge rectifier. It's not possible. only it can fix a constant DC, pulsating DC value. So that variable DC is not obtained. So DC, the diode bridge rectifier is providing fixed DC. Now, how will be getting variable DC? In the sense, for that reason, a chopper circuit is employed. Now, the fixed DC, what I'm getting at the diode bridge rectifier is passed through this filter, LC filter. This will ripple out the voltage, because here we are producing pulsating DC after the diode bridge rectifier. This pulsating DC is also fixed magnitude. This passed through this, and the ripple out voltage is connected across the DC chopper as it input. Now, this DC input, a fixed DC input voltage to the chopper, is now converted into variable DC. So how we are getting this? In the sense, here also one controller is kept. This controller will adjust the duty cycle of the chopper. By adjusting the duty cycle of the chopper, we can have variable output voltage. It may be either step down or step up. Most probably we are using a step down chopper, that is basic series chopper. If suppose we are adjusting a firing angle here, that firing angle we are terming as the duty cycle. For the case of chopper, the average output voltage is controlled. Once average output voltage is controlled, this is passed to a bulky inductor. This bulky inductor will convert this available voltage into the current source, and this current source is given as input here to the inverter, and the output terminals also functions like current sources. This current source, what we have here, is constant current for a specific value of voltage. If you vary this voltage by adjusting various duty cycles in the controller, various values of voltage magnitudes are produced at the output of the chopper. This is passed through the inductor. The magnitude of the current is available after the inductor will depending upon the voltage. For various values of voltages, various values of currents will be getting, and that currents are given as input to this inverter, so that the variable current will be getting at the output of the inverter. And variable frequency is obtained by controlling the time period of the inverter, so that variable current, variable frequency operation is obtained at the inverter. So here the induction motor now also can operate in constant I by F control. This constant I by F control is most reliable as compared to the constant V by F control, because the current control is most reliable compared to the voltage control in practically. So hence we are saying that this I by F control is most reliable. Thank you.